The Internet, or Internet, is the global system of interconnected computer networks that uses the Internet Protocol Suite, TCP/IP, to communicate between networks and devices. It is a network of networks that consists of private, public, academic, business, and government networks of local to global scope, linked by a broad array of electronic, wireless, and optical networking technologies. The Internet carries a vast range of information resources and services, such as the interlinked hypertext documents and applications of the World Wide Web, www, electronic mail, telephony, and file sharing. The origins of the Internet date back to research to enable time sharing of computer resources and the development of packet switching in the 1960s. The set of rules, communication protocols, to enable internetworking on the Internet arose from research and development commissioned in the 1970s by the Defense Advanced Research Projects Agency, DARPA, of the United States Department of Defense in collaboration with universities and researchers across the United States and in the United Kingdom and France. The ARPANET initially served as a backbone for the interconnection of regional academic and military networks in the United States to enable resource sharing. The funding of the National Science Foundation Network as a new backbone in the 1980s, as well as private funding for other commercial extensions, encouraged worldwide participation in the development of new networking technologies and the merger of many networks using DARPA's Internet Protocol Suite. The linking of commercial networks and enterprises by the early 1990s, as well as the advent of the World Wide Web, marked the beginning of the transition to the modern Internet, and generated a sustained exponential growth as generations of institutional, personal, and mobile computers were connected to the network. Although the Internet was widely used by academia in the 1980s, subsequent commercialization is what incorporated its services and technologies into virtually every aspect of modern life. Most traditional communication media, including telephone, radio, television, paper mail, and newspapers, are reshaped, redefined, or even bypassed by the Internet, giving birth to new services such as email, internet telephone, internet television, online music, digital newspapers, and video streaming websites. Newspaper, book, and other print publishing have adapted to website technology or have been reshaped into blogging, web feeds, and online news aggregators. The Internet has enabled and accelerated new forms of personal interaction through instant messaging, Internet forums, and social networking services. Online shopping has grown exponentially for major retailers, small businesses, and entrepreneurs, as it enables firms to extend their brick-and-mortar presence to serve a larger market or even sell goods and services entirely online. Business-to-business and financial services on the Internet affect supply chains across entire industries. The Internet has no single centralized governance in either technological implementation or policies for access and usage. Each constituent network sets its own policies. The overarching definitions of the two principal namespaces on the Internet, the Internet Protocol Address, IP address, space, and the Domain Name System, DNS, are directed by a maintainer organization, the Internet Corporation for Assigned Names and Numbers, ICANN. The technical underpinning and standardization of the core protocols is an activity of the Internet Engineering Task Force, IETF, a non-profit organization of loosely affiliated international participants that anyone may associate with by contributing technical expertise. In November 2006, the Internet was included on USA Today's list of the new 7 wonders. The word Internet was used as early as 1849, meaning interconnected or interwoven. The word Internet was used in 1945 by the United States War Department in a radio operator's manual, and in 1974 as the shorthand form of Internetwork. Today, the term Internet most commonly refers to the global system of interconnected computer networks, though it may also refer to any group of smaller networks. When it came into common use, most publications treated the word Internet as a capitalized proper noun. This has become less common. This reflects the tendency in English to capitalize new terms and move them to lowercase as they become familiar. In the 1960s, computer scientists began developing systems for time-sharing of computer resources. Since 1995, the Internet has tremendously impacted culture and commerce, including the rise of near-instant communication by email, instant messaging, telephony, Voice over Internet Protocol or VoIP, two-way interactive video calls, and the World Wide Web with its discussion forums, blogs, social networking services, and online shopping sites. Increasing amounts of data are transmitted at higher and higher speeds over fiber optic networks operating at 1 Gbps/s, 10 Gbps/s, or more. The Internet continues to grow, driven by ever greater amounts of online information and knowledge, commerce, entertainment, and social networking services. The Internet is a global network that comprises many voluntarily interconnected autonomous networks. It operates without a central governing body. The technical underpinning and standardization of the core protocols, IPv4 and IPv6, is an activity of the Internet Engineering Task Force, IETF, a non-profit organization of loosely affiliated international participants that anyone may associate with by contributing technical expertise. To maintain interoperability, the principal namespaces of the Internet are administered by the Internet Corporation for Assigned Names and Numbers, ICANN. ICANN coordinates the assignment of unique identifiers for use on the Internet, including domain names, IP addresses, application port numbers in the transport protocols, and many other parameters. Globally unified namespaces are essential for maintaining the global reach of the Internet. This role of ICANN distinguishes it as perhaps the only central coordinating body for the global Internet. Regional Internet registries, RIRs, were established for 5 regions of the world. The African Network Information Center, AFRI-NIC, for Africa, the American Registry for Internet Numbers, ARIN, for North America, the Asia-Pacific Network Information Center, APNIC, for Asia and the Pacific region, the Latin American and Caribbean Internet Addresses Registry, LACNIC, for Latin America and the Caribbean region, and the Réseau IP Européens, Network Coordination Center, RIPE-NCC, for Europe, the Middle East, and Central Asia were delegated to assign IP address blocks and other Internet parameters to local registries, such as Internet service providers, from a designated pool of addresses set aside for each region. The communications infrastructure of the Internet consists of its hardware components and a system of software layers that control various aspects of the architecture. As with any computer network, the Internet physically consists of routers, media, such as cabling and radio links, repeaters, modems, etc. However, as an example of internetworking, many of the network nodes are not necessarily Internet equipment per se. The Internet packets are carried by other full-fledged networking protocols with the Internet acting as a homogeneous networking standard, running across heterogeneous hardware, with the packets guided to their destinations by IP routers. Internet service providers, ISPs, establish the worldwide connectivity between individual networks at various levels of scope. End users who only access the Internet when needed to perform a function or obtain information, represent the bottom of the routing hierarchy. At the top of the routing hierarchy are the Tier 1 networks, large telecommunication companies that exchange traffic directly with each other via very high-speed fiber optic cables and governed by peering agreements. Tier 2 and lower-level networks buy Internet transit from other providers to reach at least some parties on the global Internet, though they may also engage in peering. An ISP may use a single upstream provider for connectivity, or implement multi-homing to achieve redundancy and load balancing. Internet exchange points are major traffic exchanges with physical connections to multiple ISPs. Large organizations, such as academic institutions, large enterprises, and governments, may perform the same function as ISPs, engaging in peering and purchasing transit on behalf of their internal networks. Research networks tend to interconnect with large subnetworks such as GIANT, Gloriad, Internet2, and the UK's National Research and Education Network, JANET. Common methods of Internet access by users include dial-up with a computer modem via telephone circuits, broadband over coaxial cable, fiber optics, or copper wires, Wi-Fi, satellite, and cellular telephone technology, e.g. 3G, 4G. The Internet may often be accessed from computers in libraries and Internet cafes. Internet access points exist in many public places such as airport halls and coffee shops. Various terms are used, such as public Internet kiosk, public access terminal, and web payphone. Many hotels also have public terminals that are usually fee-based. These terminals are widely accessed for various usages, such as ticket booking, bank deposit, or online payment. Wi-Fi provides wireless access to the Internet via local computer networks. Hotspots providing such access include Wi-Fi cafes, where users need to bring their own wireless devices, such as a laptop or PDA. These services may be free to all, free to customers only, or fee-based. Modern smartphones can also access the Internet through the cellular carrier network. For web browsing, these devices provide applications such as Google Chrome, Safari, and Firefox, and a wide variety of other Internet software may be installed from app stores. Internet usage by mobile and tablet devices exceeded desktop worldwide for the first time in October 2016. Mobile Internet connectivity has played an important role in expanding access in recent years, especially in Asia and the Pacific and in Africa. The number of unique mobile cellular subscriptions increased from 3.89 billion in 2012 to 4.83 billion in 2016, two-thirds of the world's population, with more than half of subscriptions located in Asia and the Pacific. The Internet standards describe a framework known as the Internet Protocol Suite, also called TCP/IP, based on the first two components. This is a suite of protocols that are ordered into a set of four conceptual layers by the scope of their operation. At the top is the application layer, where communication is described in terms of the objects or data structures most appropriate for each application. For example, a web browser operates in a client-server application model and exchanges information with the Hypertext Transfer Protocol, HTTP, and an application germane data structure, such as the Hypertext Markup Language, HTML. Below this top layer, the transport layer connects applications on different hosts with a logical channel through the network. It provides this service with a variety of possible characteristics, such as ordered, reliable delivery, TCP, and an unreliable datagram service, UDP. Underlying these layers are the networking technologies that interconnect networks at their borders and exchange traffic across them. The Internet layer implements the Internet Protocol, IP, which enables computers to identify and locate each other by IP address and route their traffic via intermediate, transit, networks. The Internet Protocol layer code is independent of the type of network that it is physically running over. At the bottom of the architecture is the link layer, which connects nodes on the same physical link, and contains protocols that do not require routers for traversal to other links. The protocol suite does not explicitly specify hardware methods to transfer bits, or protocols to manage such hardware, but assumes that appropriate technology is available. Examples of that technology include Wi-Fi, Ethernet, and DSL. The most prominent component of the Internet model is the Internet Protocol, IP. IP enables internetworking and, in essence, establishes the Internet itself. Two versions of the Internet Protocol exist, IPv4 and IPv6. For locating individual computers on the network, the Internet provides IP addresses. IP addresses are used by the Internet infrastructure to direct Internet packets to their destinations. They consist of fixed-length numbers, which are found within the packet. IP addresses are generally assigned to equipment either automatically via DHCP, or are configured. However, the network also supports other addressing systems. Users generally enter domain names, e.g. n.wikipedia.org, instead of IP addresses because they are easier to remember. They are converted by the domain name system, DNS, into IP addresses which are more efficient for routing purposes. IPv4. Internet Protocol version 4, IPv4, defines an IP address as a 32-bit number. IPv4 is the initial version used on the first generation of the Internet and is still in dominant use. It was designed to address up to 4.3 billion, 109, hosts. However, the explosive growth of the Internet has led to IPv4 address exhaustion, which entered its final stage in 2011, when the global IPv4 address allocation pool was exhausted. PV6. Because of the growth of the Internet and the depletion of available IPv4 addresses, a new version of IPv6, was developed in the mid-1990s, which provides vastly larger addressing capabilities and more efficient routing of Internet traffic. IPv6 uses 128 bits for the IP address and was standardized in 1998. IPv6 deployment has been ongoing since the mid-2000s and is currently in growing deployment around the world, since Internet Address Registries, RARs, began to urge all resource managers to plan rapid adoption and conversion. IPv6 is not directly interoperable by design with IPv4. In essence, it establishes a parallel version of the Internet not directly accessible with IPv4 software. Thus, translation facilities must exist for internetworking or nodes must have duplicate networking software for both networks. Essentially all modern computer operating systems support both versions of the Internet protocol. Network infrastructure, however, has been lagging in this development. Aside from the complex array of physical connections that make up its infrastructure, the Internet is facilitated by bi- or multilateral commercial contracts, example peering agreements, and by technical specifications or protocols that describe the exchange of data over the network. Indeed, the Internet is defined by its interconnections and routing policies. A subnetwork or subnet is a logical subdivision of an IP network. 1.16 The practice of dividing a network into two or more networks is called subnetting. Computers that belong to a subnet are addressed with an identical most significant bit group in their IP addresses. This results in the logical division of an IP address into two fields, the network number or routing prefix and the rest field or host identifier. The rest field is an identifier for a specific host or network interface. Computers and routers use routing tables in their operating system to direct IP packets to reach a node on a different subnetwork. Routing tables are maintained by manual configuration or automatically by routing protocols. End nodes typically use a default route that points toward an ISP providing transit, while ISP routers use the border gateway protocol to establish the most efficient routing across the complex connections of the global Internet. The default gateway is the node that serves as the forwarding host, router, to other networks when no other route specification matches the destination IP address of a packet. The Internet carries many applications and services, most prominently the World Wide Web, including social media, electronic mail, mobile applications, multiplayer online games, internet telephony, file sharing, and streaming media services. Most servers that provide these services are today hosted in data centers, and content is often accessed through high-performance content delivery networks. Thank you.